Hello guys, today we are going to learn topological sort. So what is topological sort? Topological sort exists in a directed graph, okay, DAG, so directed acyclic graph, okay. So the graph which does not have any cycle, that kind of graph we can have a topological sort. It is nothing but the linear ordering of its vertices such that for every directed edge, let's say u and v, from vertex u to v, u comes before v. Okay, let's take this example. 3 is a node, then there is 2, 3 to 2 there is a directed edge, okay, and there is another one directed edge to 0, node 0, okay, and from 2 there is a directed edge again, and let's say there is another node 1, and from 2 there is an edge like this, okay. 2 and 1 are connected like this, okay. So you can see that this is a graph, and let's see if there is a cycle. So you can clearly see there is no cycle here, that's why it is called directed acyclic graph, okay. Fine. How will we solve this particular graph? In fact, to solve this graph, what we need to know is in degrees for each vertex, okay. So in degree for a node is nothing but the number of incoming edges to this particular node. For example, 1 is the in degree, okay. So because only one edge is coming towards this node. Now let me mark this in degrees. For 2 we found 1 is the in degree, okay, right. Now for 0 you see 2 edges are coming towards 0 node, right. That's why the in degree is 2, okay. And now for this 1 node in degree is 1, okay, and see 3 all the edges are going out from this node, right. There is nothing incoming, that's why it is 0, okay. Now you see in this particular graph we have a node whose in degree is 0, okay. So which means there is no edge which is coming towards this particular node, and this is the node that can be used for actually traversing this graph, okay. And how do we traverse? We are actually going to do a breadth first search, okay. We are going to use a queue and we are going to traverse this particular graph. Let me show you in Java how did we find the in degrees for all these nodes. Let's say we have this class called directed graph node. This class represents each node, okay, each vertex of this particular graph, and it has a member called label and it has its neighbors, okay. For example, for this 3 neighbors are 0 and 2 and label is 3. So let's say we are given the list of nodes in the graph, then we can create the in degrees by traversing all the nodes in the graph, okay. We'll first initialize in degrees for all the nodes at 0 and for each connected node, so each neighbors, right, for each node's neighbor, what will we do? We'll go and count the in degrees by connected node first, and then we'll update the in degrees with their count, okay. So I think it is not very difficult, but this is the first step that we will do while solving for a topological sort. So find in degrees for each node. Fine, that's good. Now we have all the in degrees, and now the next step is find the nodes which have 0 in degrees, okay. Clearly here number 3 has in degree 0, okay. So we'll start from here. So we'll start traversing from here. So if there is another node which has in degree 0, we could have actually started from that node also, okay. Now what will we do? We look at the neighbors for this particular node whose in degree is 0, so 3. So for 3, 0 and 2 are neighbors, right, and we'll start removing these edges, okay. So we'll remove this edge and this edge also. When we'll remove these edges, what will be the in degree for 0 and 2? It will be 1, right. So for 0 this will be 1, and for 2 it will be 0, right. Let me just remove these edges, then it will be clear. I'll remove this, okay, and now 2 becomes 1, right. I'll remove this and now for number 2, 0 is the in degree, right? Okay, now we are done with 3. Now the next node who has in degree 0 is 2, right? So we'll pick 2, okay, and from here we'll look at all the neighbors, okay, neighboring edges, okay, and now we'll remove them, okay. So we'll remove this, so and then we'll remove this, okay, and we'll update the in degrees, right? So this will become 0 and this will also become 0, right? Let me just write the node that we are considering right now. So it is 2 right now, and remove this, okay, and now in degrees also we updated, okay. So right now if you see 0 and 1, so any one we can pick and we can continue the DFS, okay. So I'll say 0, and then it does not have any neighbors, so I'm done with this 0, okay, and next one is 1, so I'll pick 1, and it also does not have any neighbors which we can connect to, right? So that's also done. 3, 2, 0, 1. So this is the topological ordering for this particular graph, 3, 2, 0, 1, okay. In fact, we could have actually first selected 1 and then selected 0 also, right? So that's why it has another ordering which is 3, 2, 1, 0 also, okay. So this is good, okay. Now let's take another example. Let's say this is our graph, 1, 2, 1 is connected to 2 like this, then let's say this is 4, 1 and 4 are connected like this, and there is a directed edge like this, 2 to 4 is connected, okay, and 2 to 3 and 4 to 3, and there is another one, let's say 5, okay. So let's see if we have a cycle, and you can clearly see there is no cycle, and again we'll find the in degrees for all these nodes, okay. Clearly this is the node for which in degree is 0, this is 1 again, this is 2, and this is 2, and this is 1, right? Let's start from 1 because it has in degree 0, so I'll say 1, okay. I'll remove the connected edges from 1, okay. I'll remove this, okay. Now this will become 0 and this will become 1, right? So I'll say this will become 0 and this will become 1, right? Good. Now next node that we'll pick is number 2. So this is the node we are going to take right now, okay. So I'll say take this node, okay. Now we are going to remove the edges which are connected to 2. So remove this, and update the in degrees. This will become 1, this will become 0, right? Fine. Now we'll pick the next one. Next one is 4, right? Okay, so we'll write 4, okay, and now we'll remove the edges which are connected to 4. So remove this, and update the in degrees, okay. So this will become 0 and this will become 0, right? Remove this, okay. Now we have this 3 and 5, and we can go in any order. Actually we can pick first 3 or 5. So I'll pick 3 first, okay, and now you see there is no more neighbors for 3, so we are done with this node. And next is 5, so we'll take this 5 here and we'll see if it has any neighbors, and it doesn't have, you can see, and so we are done, okay. So this is one order we found, and another order is we could have taken 5 first and then 3, right? So another order could be 1, 2, 4, 5, 3. Okay. Now in terms of coding, if I will think, then what we are doing, we are actually going to put the node whose in degree is 0 into a queue, and then after that we will look at all the neighbors for that node. So that can be a for loop, right? Then we will start decrementing all the in degrees for all those connected nodes. This is how the code will look like. After we have calculated the in degrees, we must find the nodes which has in degree 0 to start with our BFS traversal. This is done here in a simple for loop, and after that we start the BFS with the queue. Queue should have at least one node to start with. Okay, it can have multiple, but it will at least have one node to start with. Now we'll start the while loop until the queue is empty. So it is exactly BFS traversal, nothing new here. We'll poll the node that goes to the result. After that, for each connected node, for the node neighbors, okay, we are going to get the count and we are going to update the in degrees. I mean, this is the process where we are actually deleting the edges and updating the count. Actually, there is no such instruction called deleting the edges, because it is nothing but just decrementing the count, right? So we are just getting the connected nodes in degrees count, and we are just updating the count, and each time we see the count is 0, we are again pushing all those nodes into the queue. So this is it. This is how we can find the topological ordering for a given directed acyclic graph. Okay, thanks for watching, guys. See you next time. Until then, bye, take care.